Hi there, and welcome to the first video of this brand new series, which we're calling MLITH, which is short for Machine Learning Isn't That Hard. We named it that because machine learning actually isn't that hard. Now, this series is divided into two seasons. Season 1 is for machine learning, and season 2, where we'll dive deep into deep learning. So, every video in this series is of two forms, the theoretical aspect and the practical aspect. The theoretical part is where I'll mostly be talking to you guys like this or explaining stuff on the drawing board. And the practical part is where we get some hands on experience and implement the stuff we've learned in the theoretical part. For the practical part, we've chosen Python to be the primary programming language. It's because it's easier to write and understand code in Python. And also, Python has great support for amazing machine learning libraries. So, in the first season, the machine learning season, or this particular playlist, we'll cover various topics under machine learning. We'll look at what machine learning is, a little bit of its history, different learning problems in machine learning, and different algorithms under each learning problem. Then we'll move on to different types of data, where we'll look at something known as EDA, which is short for exploratory data analysis, which is one of the most crucial phases of training your models. Then we'll move on to using the algorithms to train the models. Finally, we'll evaluate the performance of our trained models, where we'll realize the importance of train, validation, and test sets. And probably that'll be the right time to talk about something known as metrics, and using the metrics to tune your hyperparameters to improve the performance of your model. After all that is done, we'll just go ahead and deploy our trained machine learning models and provide an API service so that users can interact with the API and make use of our trained models. So yeah, it may seem like there are very few topics to cover, but then there's a lot to learn and a lot to explore. So without further ado, let's get started. First off, let's get some basic intuition of what machine learning is. Let's start with an example. Say you have the numbers 10 and 2 and you want to add them. So you open up your laptop, PC, or your mobile phone and enter the numbers 10 and 2 into the calculator with the addition operator. So basically, you have given the calculator some data and an operator or a rule, and you need to get the answer from the algorithm. So this is what all traditional algorithms do. They take in some data, they take in some rules, they apply the rules on the data, and they compute some answers. That's pretty straightforward. So, is there a way you can write a computer algorithm to differentiate between a cat and a dog? Take a moment to pause and think what you could do. This is when machine learning kicks in. In traditional algorithms, we have data and rules, and we derive answers. In machine learning, it's the other way around. Instead, we have data and answers associated with the data, and we derive the underlying rules that are used to obtain the answers from data. Little confusing? Let's hop back to the cats versus dogs example to get a better understanding of what this means. Say we have a set of images of cats and dogs, and we tell our computer algorithm that these are cats and these are dogs. So our computer algorithm needs to define those rules to differentiate between cats and dogs. So when we are given a new image of a dog, it uses those learned rules to differentiate if this particular image is a cat or a dog. In this case, it's a dog because our model has learned. Note that I'm using the term model and not an algorithm because that's the term we use for machine learning algorithms. And the process of learning these rules is called model training. So it's very important to use the term model. So let's go ahead and check out the definition of machine learning. A computer program is set to learn from experience E with respect to some class of tasks T and performance measure P, if its performance at tasks in T as measured by P improves with experience E. And this was stated by Tom Mitchell. So let's break this down. Let's take humans, and we are given some set of tasks. So basically, as we are doing those tasks, as our experience increases, as we spend more time in doing those tasks, then we get better and better at those tasks. So the same thing that's extended to computer algorithms, or in this case, machine learning algorithms. So let's get into different learning problems. We have supervised learning, unsupervised learning, and finally we have the reinforcement learning. So these three are primarily the most important divisions or learning problems in ML. Yes, we have other hybrid forms such as semi-supervised or self-supervised. We'll get into them later. Let's talk about supervised. So in supervised learning, as the name says, we have the model training under our supervision.
We have some input data, we have some answers associated with it, and we only tell our algorithm to learn the mapping from the input data to the answers, right? So everything is labeled for us, the data and the answers. Let's say we have a mathematical function y equal f of x. So basically f maps from x to y. We are given x and y. All we are telling our model to learn is the mapping f. So let's take an example. Here we have a plot, a scatter plot, and we have our x and y values, and there is some sort of mapping between x and y, which is represented by those scatter dots, whatever, right? Now our model is trying to learn the line in between, which is the most general representation of the mapping, which is also known as the best fit. Now this best fit line represents the mapping, or it is the most general mapping between x and y. Now let's get into unsupervised learning. Unlike supervised learning, in unsupervised learning, we do not have any answers to feed into the model. So the model has to train itself just using the underlying patterns in the input data. Let's say you get a call from a scammer. Though you haven't spoken to any scammer prior to this, you can easily find out that it's a scammer. So you use the underlying pattern or in the conversation to find out that it's a scammer. So let's take this diagram for example. I'm just taking off the title to avoid confusion. Though we do not have any labels associated with each data point, we somehow know by seeing it or by visualizing it that we can easily separate each data point into separate clusters. So that's basically using the underlying data pattern to separate it into different categories. And lastly, we have reinforcement learning. Let's take a cute example here. Let's say you have your pet dog and you want to train your pet dog to jump through a hula hoop. Obviously, your pet dog is not stable, so probably it might just run away or just jump, or it might just dance and eat, or probably even sleep. But let's say by chance, just by chance, your pet dog takes the right step and jumps through the hula hoop. So you give it a reward which it likes. And since it likes the reward it gets, it keeps jumping through the hula hoop, or it learns to jump through the hula hoop because it wants to get more rewards. That's exactly what we do in reinforcement learning. We have an agent, in this case we have our pet dog, which is kept in an environment, and it can take a set of actions, 80 in this case, and each action is associated with some reward, and the agent has to take actions which maximize its rewards. So our pet dog eventually jumps to the hula hoop. So in today's video, we give a brief introduction of what machine learning is, a little bit of its history, and different kinds of learning problems present in machine learning.
So yeah, we covered a lot in today's video and hope that gives you a head start into the world of machine learning. Please leave your questions, comments and suggestions in the comment box. And just like the video if you really did. Subscribe to the ML Veda if you already haven't, and turn on the notifications so that you don't miss out on fresh content from the ML Veda. Also, I have an announcement to make. We are close to hitting 100 subscribers. We are at 93 and growing. So I just want to thank all of you for all the love and support you guys are providing. It really motivates me to make all this content for you guys. I just wanted to thank all of you. Yeah, we have a lot to learn and a lot to cover. So see you in the next episode of MLITH Season 1. Until next time.